The next learning outcome is to calculate and interpret the future value and present value of a single sum of money, an ordinary annuity, an annuity due, a perpetuity, present value only, and a series of uneven cash flows. First, we will focus on the future value of a single sum. Future value is the amount to which a current deposit will grow over time when it is placed in an account earning compound interest. Future value is also called the compounded value. It is simply the manifestation of compound interest at work. The formula for finding the future value of a single sum is future value equals present value times the quantity 1 plus the periodic interest rate raised to a power equal to the number of compounding periods. In other words, the future value is the present value compounded at the periodic interest rate over the number of compounding periods. Please note that the quantity 1 plus the periodic interest rate raised to the number of compounding periods is referred to as the future value factor or future value interest factor for a single cash flow. At this time, I'd like to discuss the keys that you will be using on your financial calculator. The third row from the top on the TI BA2 Plus contains the time value of money keys. The N refers to the number of compounding periods. I over Y is the interest rate per compounding period. PV stands for present value. PMT stands for payment and is used with annuity problems, and FV stands for future value. One annoying feature of the TI BA2 Plus is that it comes preloaded from the factory with the payments per year function set to 12. This will automatically convert the number of years N into months and an annual interest rate into monthly rates. While this feature may be appropriate for many types of loan problems, it is not suitable for the majority of the time value of money applications that we will be discussing during this reading, or for the time value of money applications that you will see on the exam. So, be sure to set the P over Y, or payment per year key on your calculator to 1. The P over Y function on the Texas Instrument BA2 Plus is located above the I over Y key. To change payments per year to 1, press second, press I over Y, press 1, and press Enter, which is the second button from the left on the top row of the BA2 Plus. Press second again, and press Quit, which is located directly above the second key. In the examples that follow, we assume that you have cleared the time value of money function keys prior to each problem. This is accomplished by pressing the second key and then the FV key. Your calculator will remember the last stored values otherwise, even after it has been turned off. Alternatively, whenever you input values into 4 of the TVM variables and solve for the 5th, you have replaced all values and should have no problems, even if you haven't separately cleared the TVM registers. Let's consider an example of how to compute the future value of a single sum. Suppose we want to calculate the future value of a $300 investment at the end of 10 years if this investment earns an annual compound rate of return of 8%. To solve this problem on your calculator, you press the number 10 and then press N, because 10 is the number of compounding periods. Then you press 8 and press I over Y, because 8 is the interest rate for each compounding period. Now enter 300 and press the negative sign, and then press PV. We can compute the future value by pressing CPT, and then FV. The compute key, or the CPT key, is located in the upper left-hand corner of the TI BA2 Plus. In your display, you should have $647.68. If you didn't make the present value a negative entry, the future value would have been a negative number. You could have just ignored the negative sign, which is acceptable for simple problems involving single sums. Now let's discuss the present value of a single sum. The present value of a single sum is the future value divided by 1 plus the interest rate per compounding period raised to the number of compounding periods. This quantity, 1 divided by 1 plus the interest rate per compounding period, is referred to as the present value factor or present value interest factor. It is also referred to as the discount factor because the process of taking present values is also referred to as discounting, or determining the discounted value of a future amount. Let's look at an example. Let's assume that the discount rate for the interest rate per compounding period is 9%, and that we want to know the present value of a $1,000 cash flow that will be received in 5 years. We can divide 1,000 by 1 plus 0.09 to correspond to the 9%, raised to the 5th power to correspond to the 5 years, or we can simply use our calculators by entering n as 5, the interest rate per compound period, or the I over y key, as 9%, FV equals 1,000, and compute using the CPT key, PV. In the display, we have negative 649.93. We can simply ignore this negative sign, or we could have entered the future value as a negative 1,000, and then the display would have been a positive 649.93. The negative sign in this case could be interpreted as the amount of cash outflow required today to generate $1,000 in 5 years if the cash outflow earned 9% per year. The results of our example imply that at a discount rate of 9%, an investor will be indifferent between $1,000 in 5 years and $649.93 today.